Hello and welcome to Prescriptive Analytics. We are now going to move on to the next stage of linear programming, and we're going to call that integer linear programming. In this section, we'll be discussing binary variables, how to use binary variables, how to actually get integer solutions rather than decimal solutions. My name is Hari Rajgopalan, and I'll be walking you through this lecture. So let's talk a little bit about why this is so important compared to what we have done so far. When we did linear programming, sometimes we get solutions which are in decimal values. However, we do have problems where we must have integer values, and these occur very frequently in day-to-day life. For example, scheduling workers. You cannot schedule half a worker. Manufacturing planes. You cannot manufacture half a plane. Integer variables allow us to build more accurate models for a number of common problems. So let's take this whole Blue Ridge hot tubs. Remember the aqua spas and hydroluxes. We were trying to maximize aqua spas and hydroluxes, and it's subject to a certain number of constraints here. Now, one of the things which we did not specify was that this x1 and x2 must be integer. And the integrality constraints are easy to state, but they make the problem much more difficult and sometimes impossible to solve. So the original ILP essentially is integer linear programming of any kind of thing. Here's the one where we are looking at 2x1 plus 3x2 maximization. Here are the constraints, and x1 and x2 must be integers. And the LP relaxation is when we remove these integer constraints. When solving using LP, it's much more easier. All the solvers can solve the LP problems pretty quickly. But when it comes to integer linear programming, sometimes it can run forever. And therefore, a lot of times people say, well, why don't we just round them up? And we'll talk about it. So let's take an example of a 2x2 problem. Here is the LP feasible region, which is in the blue region. And we all know that the maximum, if we draw the line and we keep moving it up, the maximum value could be somewhere here. However, the integer values, you've got to look at these. It could be 1, 1, 1, 2, can't be 3. It could be 2, 1, and 2, 2, or it could be 3, 1, right? So these could be the feasible, and of course here, 0, 2, 0, 1, 0, 0, 1, 0, 2, 0, 3, 0, right? So these could be the integer feasible values. So sometimes when you solve a linear programming relaxation, you get lucky and you get an integer feasible solution. So this was the original case with Blue Ridge hot tubs from earlier chapters. But if we did reduce the labor hours to 1520 and amount of tubing to 2650, you'll see that your solution now has decimal values. And we'll talk about how rounding off doesn't just help. So the optimal solution to an LP relaxation of an integer linear programming problem gives us the boundary or the bounds of this is the maximum we can get. And for maximization problems, the optimal relaxed objective is the upper boundary. And for minimization problems, that becomes the lower boundary. So your LP relaxation will always be better than your ILP solution. Better than or equal to. It is tempting to round things fractionally, and I'll show you why this is a problem. In general, this does not work. Reliability, rounded solutions may be infeasible or they may not be the best solution. So let's go to Blue Ridge hot tubs in Excel and I'll show you what this is, what we are actually talking about. Okay, so we have here the Blue Ridge hot tubs problem. And here's the original problem. Aqua spas is x1, hydroluxes, number of hydroluxes is x2, and you see you are able to get 66,100. But let's change the solution. Instead of 1566 and 2880, let's assume we have 1520 and 26. Labor is only 1520 hours and tubing is 2650. So when we rerun the problem changing these two, you will notice that you get 116.94 aqua spas and 77.916667 hydroluxes. Now you can't build 0.94 or 0.92. So obviously that's going to be a problem. You can try rounding up. So I'll round up to 117 and 78, but that will violate the labor and tubing constraints. You see here, it should be less than 1520 and 2650. Here it's more, so that's not going to work. So let's go round down 116 and 77. This actually gives us the values, and these are feasible, but is 63,700 the best value that you can get? So this is the rounded solution, 63,700. But what we can do instead of rounding it is you can go, let's copy this. And let's go ahead under constraints, go to constraints, select all your variables, and then say they are integer values. This Excel will then force these to be integer, and then you rerun it, and you'll notice it allows you to build 118 aqua spas and 76 hydroluxes, giving you a profit of 64,100, which is about $400 more than rounding off solution. So the rounding off solution is suboptimal, whereas putting the integer constraint is actually the optimal solution. So this tells you why rounding off doesn't really work, and that you need to ensure that this is an integer. Now the problem you have with larger problems is when you have an integer problem, sometimes your Excel file will keep running because it's hard. The LP, linear programming, will solve things very quickly and give you an optimal solution. But integer linear programming sometimes can keep taking a long time. All right. So we'll stop here and get to some real world problems.